Good morning. It's my pleasure to present our work, PageFlip, leveraging page flipping gestures for efficient command and value selection on smartwatches. My name is Teng. I'm a PhD student at the University of Manitoba, and this work is in collaboration with a lot of people. Jiannan from University of Toronto, Keisuke, Randy from Honda, Khalad from University of Waterloo, and this work is supervised by both Ravin and Pourang. So smartwatches are becoming common and rich in information. However, due to the small size problems and the fat finger problems, navigating the menu selections are still challenging because it usually requires users to perform a sequence of taps and swipes, which could be tedious and time-consuming. Of course, there are a lot of exciting and promising work on investigating how to improve the efficiency of touch input and a lot of portion on that are leveraging the dexterity of our hands or the fingers. Just to give a few examples, the multi-finger mouse leverages the fingers to mimic a mouse, and the users can select and operate the menu systems just in the way similar to using a mouse. Gesture search enables the stroke-based gestures for search and access commands in a very quick way. And the pin and across, where the authors leverage the dexterity of the two fingers of our hand, and the users can tap on the object to invoke the command, and then select the command by crossing over the target using the other finger. So these approaches are pretty promising and efficient. But when we come back to these scenarios of the smartwatch uses, we realize that many of these applications or the approaches are not applicable because the small size of the screen actually reduced or limited our dexterity of the fingers, and thus the expressivity of our gestures. So on smartwatches, researchers prefer to use the more simple and directed gestures, such as the typings and the swipings. And the faster command is a very good example, where the users can tap on the one finger with one finger to invoke the command, and tap on the command with another finger. And as the users learn more about that, they get very familiar with the layout, and this task can be done in a very quick way. However, the faster command didn't consider the feasibilities of using the continuous input on the smartwatch. So we would like to explore what are the alternative approaches that we can use to support the efficient menu selections on smartwatch. Then we get some inspiration from this very common daily task, page flipping, where you are reading a book. Although this is a very simple action, there are some interesting observations. For instance, a user can flip different corners of the book. A user can flip the corner to different directions and to different distances. And we can also flip multiple pages at a time. So we wonder how we could actually apply these observations or the interesting features to design a menu selection mechanism that works for the smartwatch. So we designed the PageFlip, new menu selection mechanism for command and value selection on smartwatch. So instead of typing, users need to drag the corner to a certain direction and to a certain distance to invoke the command. Releasing the finger will confirm the selections. Here shows a quick demo of PageFlip. In this video, a user drags the right top corner to change the color or the text size of the text. And he can also use the second layer corner to reset if he is not satisfied with that. He can also use a different corner to select a contact and send the message. So why we think PageFlip is an interesting approach? There are some advantages of PageFlip. First of all, different corners can be used as the PageFlip, and when users, this explores the user's spatial memory of the corner command mappings. And the users can drag a corner to select a command and value in a single action. This reduced the requirement for the frequent typings and swipings. And the second, a corner can be dragged into a different direction and different distances, which we could use this information to design a hierarchy menu layout, which I will show you later. Third, users can use this stacked page layout to make the PageFlip applications more scalable. So besides proposing this design concept, we did 2 user studies to evaluate PageFlip as a menu selection mechanism. In the first study, we focused on the basic design parameters of PageFlip, including corners, drag directions, and drag distances. So first, we expect that different corners will have different affections on the performance. So we'd like to see how using different corners would affect the final performance. Second, for each corner, we divide each corner into 3, 5, or 7 levels of distance segments and directional segments and distance segments, so that we would like to see how reliable users can drag the page to a desired target on a certain direction and to a certain distance. So this shows the procedure of the task in which users drag the corner and map the current selected segment to the target one. Here shows the video of a user doing the experiment. Okay, so the result, first of all, it shows that the top corners outperformed the bottom corners, and the bottom right corner took the longer time and introduced the more error rate. This is because all of our participants were right-handed, and when they used the index finger of their right hand to drag the corner on the right bottom corner of the smartwatch, they need to either switch their tilt their head or their wrist to make the target and the currently selected segments visible to them. So this actually make it very difficult to use for the right bottom corner, and we expect that there will be some similar result if for the left right bottom corner if the user is left-handed. And second, as for the distance segments and the angular segments, the more levels we have, the more time users need to spend to accurately select a target. And in the second study, we evaluated the performance of PageFlip as a selection mechanism and compared it with a radial menu, which has equivalent functions to PageFlip, and the standard swipe type menu, which we use on our existing smartwatches. The radial menu is functionally equivalent to PageFlip, as it also allows users to invoke a command and select a menu in a single step, meaning they don't need to leave their fingers until the task is done. We designed 6 tasks to compare the 3 techniques, including selecting a number, letter, or shape, which are discrete values, and changing the color, stroke weight, and size, which are continuous values. So in this video, I'm going to show you more details about the 3 techniques. With PageFlip, users drag the corner to either change a discrete value or the continuous value. And with the radial menu, users first need to long press on the screen to invoke the commands, and then he strokes towards the available command, and then he needs to swipe up and down to select the values. This also supports both the discrete and the continuous value. And with the swipe type, it's just a sequence of tap and swipes, similar to our current implementations. And we introduced a SIG bar to allow them to select the continuous value. And the results showed that for both discrete and continuous values, PageFlip will take a shorter time for the users. And with the swipe type, especially for the continuous value, it took much longer time. It's because we found the users often have some difficulties on select the SIG bar, which is pretty small. So with this, the studies, where can we apply the PageFlip to our smartwatches tasks? So I have already shown you this example where users can use different corners to change the text size or the text color. He can also use the stacked layers to do the reciting. And select contact from the contact list with a different corner. After sending the message, he could swipe using the red bottom corner to flip to a new page and start to edit a new application, new message. Besides of this, PageFlip can be also used in this notification applications where he received a notification of Facebook. He could either use the PageFlip gestures to preview the content and continue flipping to switch to the page Facebook, or he could just dismiss the notification by swiping the corner back. PageFlip can also be used in this Python Stancy example where the user brushed the Z letter on the picture. And he then dragged the red top corner to invoke a copy command. And flipping to the next page, he will see the copied content are already there on the second page. So as for the discussion, first, based on the studies and the scenarios, we think PageFlip is an intuitive and efficient menu selection mechanism that can be used on smartwatches, and I hope you agree with me on that. But we also know that there are some very important usability challenges, including the discoverability, affordance issue, and the learnability issues, which we haven't solved in this project. As with PageFlip, users can only see the command after they flip the page. So this requires the user to remember the corner and command mapping relationships. So designing a good mapping of the corner and the commands, and designing a good tutoring system for the users to memorize those mappings is a pretty challenging process for both designers and the users. Besides of this, as more and more smartwatches are with round faces and there is no corner, so how we could apply the benefit or the technical PageFlip to the smartwatches with the round corners. So this will be one of our next work. So to conclude, we explored the design and the performance of PageFlip, a technique that leverage corner command mappings and support command invocation and value selection in a single step on smartwatches. And I would like to thank you for the listening, and I'm happy to take questions.
Can you say anything about the bit rate of this entry? So you had the metric in terms of time to complete task, but how many different choices were in that selection?
Sorry, can you speak it louder? Didn't
Sure. I'm wondering if you can say anything about the bit rate of the entry. So
bit rate.
Yeah. So converting the time to complete task, in the denominator, and the number of selections in the numerator.
Oh, so I guess the question is about we have limited items to select, and then the time to spend on selecting an item. So for now, I think this is two way. For one way, because we don't use the direct typing, then we can actually design the menu items into very smaller font or sizes. Then it allows us to list more items at a time. But on the other side, we only have 4 corners, and maybe we can divide them into 3 different directions. And then regarding to this, we still have the kind of like a limited space for the menu layout, such things. So the bit rate could be kind of low for that.
Hi, Ken Hinckley, Microsoft Research. I like this work a lot. Great job. I was curious. You showed some cases where you could kind of flip the page back and you could pin it and then flip another one, so you could get like the multi.
Yeah.
I kind of missed how that worked. Like, how do you separate that from the normal interaction? And does that add to the error rate, or did you test that in the study? I missed that aspect.
Right. So for supporting that action, we actually designed a page flip gesture, which I didn't include here, but basically we use the dwell time, like and the distance. If you swipe a page corner to a short distance and hold it here, it's kind of like you stack it there, and then we think this is kind of like you leave the first layer, and then you are managed to able to flip the second layer.
Thank you.
Yeah. Thanks.
Thanks for this thing.